Hello friends, how are you all? I hope you all are fine. Today we are going to find the expression of this triangular law of vector addition because by this expression we can easily calculate the magnitude as well as direction uh, of any when these two directions apply on a particle simultaneously. We can find the resultant direction as well as the magnitude. For that, we must know this expression. In order to find the expression, let me revise this concept of triangular law. Suppose we have a particle and we apply some force in this direction and another force in this direction at the same time. It is always that when we apply these two forces on a body at the same time, this body will change its magnitude as well as direction. But the question is, what will be its next direction? What direction will it follow? In which direction will this go? And another thing is that what will be the next magnitude of this ball. For that we use this triangular law of vector addition. According to the triangular law of vector addition, if you have such a kind of situation, you can draw this vector, first vector in which we apply this direction, and this does not matter which one you first draw. Either you can draw this, either you can draw this. But always remember, when you add these two vectors, don't change its direction. In which direction these arrows are directed, you must remain the same direction, and also the size of these arrows. This is the important point regarding this vector addition, triangular law of vector addition. Now, this does not matter whether you first add this or this, because we know, according to the commutative law of vector addition, triangular law of vector addition, this does not matter. A plus B, A vector plus B vector gives us B vector plus A vector. This does not affect here. Now, let me add these, and always remember, add the second vector's tail of the second vector with the head of the first vector. In case of triangular law of vector addition, you must remember this. And this triangular law of vector addition tells us that when you have these two vectors, this third side of this triangle, if you make this triangle, this third side of this triangle will give you the resultant magnitude as well as direction. And but in today's lecture we are going to find this r. What is the expression of this r? How we can find the expression of this r, and then we can easily find out the values, find out the numerical values. For that, let's understand this figure first. All right. First, we'll find magnitude of r. Magnitude of r vector. Here we have a vector a in this direction and another vector in this direction, which are apply on a particle on a system at the simultaneous at the same time. And the resultant of these two gives us r. That is a resultant direction as well as resultant magnitude gives us this r. But we must find this r. What is actually this r? The expression of this r. For that, let me first draw here. You can find here. Let me draw first the perpendicular in order to make this right angular triangle, which will help us in dealing this situation. Now I can write, as we know from the figure, you can see this OP vector. I can write given. This OP vector is equal to this A. And another thing, this vector PQ is equal to B vector. And this theta is the angle between this vector A and vector B, inclined angle between vector A and vector B. We produce this perpendicular, that is qn. Let me call this qn, which is perpendicular to the line OP, vector OP. From this triangle QNP, you can see here, from this triangle QNP, I can write triangle QNP. If I find cos theta first, that is cos theta we know is equal to that is base divided by hypotenuse. Here our base is, when we see this triangle, this base is PN, NP or PN, and hypotenuse is this, that is PQ, which is equal to, we get Pn vector is equal to, this PQ is when we talk about this PQ is already equal to this B. Let me write B cos theta. All right, this is our equation first, remember this. Also sin theta, we know sin theta is equal to perpendicular divided by hypotenuse, which is equal to, here when we talk about this triangle, this is our perpendicular, that's QN or NQ. Let me write QN divided by hypotenuse is again this PQ, that is equal to B PQ, and I can write again, that is QN vector, that's QN is equal to, let me write this QN, not, we are dealing with magnitude only. QN is equal to, that is PQ is equal to B sin theta. If you want to write, just write this first. Pause the video and just write this first. I will rub this. All right, now I will rub this. Now we know this resultant vector, that is the magnitude of this resultant vector, that is OQ, is equal to ON plus NQ. I can also write this in terms of this Pythagoras theorem, that is, I can write hypotenuse square, that's OQ square. OQ square is equal to base square, that is ON square. Now it is from O to N. ON square plus this perpendicular square, that's NQ or QN square. NQ square. All right. Now I can write OQ square is equal to, that is ON square is equal to, ON square is equal to, I can write in this way, that is OP and PN, because when we sum up this OP and PN we get ON. I can write in this way, that is OP plus PN square plus NQ square. All right. Now this OQ square is our resultant, that is R, that is R square, which is equal to R square. Now I can write R square is equal to, see here, this OP is equal to A vector. Our OP is equal to A vector. I can write OP is equal to A vector plus this PN. This Pn is equal to, because we know from the first equation, that is Pn is equal to B cos theta, if you remember the last equation. Now I can replace this by that, that is B. Let me talk about only this magnitude. I will not draw the direction. That is b cos theta whole square plus this nq square, this nq square, nq square. We find this nq is equal to, that is b sine theta, if you remember the last two equations. Thus we can replace this nq by b square sine square theta. All right, now I can write r square is equal to, this becomes a plus b ka whole square, that is a square, that's a square plus b square, that's b square cos square theta plus 2ab, that's plus 2ab cos theta plus b square sine square theta. All right, now I can write r square is equal to a square plus b square. I take this b square and b square here common, and inside becomes, that is cos square theta plus sine square theta plus 2ab cos theta. All right, let me first write this. If you want to write this first. All right, now I will write this above step and write this step again. As you know, this cos theta, cos square theta plus sin square theta is equal to 1. Then I can write r square is equal to a square plus b square plus 2ab cos theta. Also we can write r is equal to, that is under root of a plus b plus a square plus b square plus 2ab cos theta. And this equation gives us the resultant magnitude of the this new resultant direction in which the vector goes, in which direction after applying these two forces on a body at the same time. The next magnitude of the body will be given by this equation. That is, you must know first of all this a square, a and b, and you must also know this angle that is given here, that is angle our angle theta. If you know this angle theta, you can easily find out the magnitude. You can easily find out the magnitude of this direction. All right, remember this equation. Now we are going to find the direction of this r. This is the magnitude of this r in case of triangular law of vector addition, and we get the same result in case of parallel law of vector addition also. This does not make any difference. These two are equivalent. We discussed this already, that these two values are equivalent with each other. Both these two, this vector addition, triangular law of vector addition, and this parallelogram law of vector addition, both these gives us the same values. This is our choice, which one we want to choose in order to find out our result of any numerical. Now direction. Now how can we find the direction? The direction gives us this angle, because if this angle changes, automatically we get, if this angle increases, that means the new direction will be in this way, and when this goes in this way, we get some change in theta, that's in angle, and this angle also changes our direction. and this angle gives us the direction, not this angle theta. That means we must know about this b, that's beta. Now I can write here tan beta is equal to, that is why I can use beta here, tan beta. Why I use this tan, not we have sine as well as cos. Why I use this tan? Because we know that tan is equal to, if we talk about this tan theta, we know that this tan theta is equal to, that is sine divided by cos theta. Sine is equal to perpendicular divided by hypotenuse, and this is equal to base divided by hypotenuse. Hypotenuse will cancel, that is perpendicular divided by base. And here we find that in our given figure, we know this perpendicular as well as base, and we do not know regarding this. If we directly want without any this if we not know any this r, we can easily find its direction without this r, because if we know this a as well as this perpendicular, if we know this base as well as perpendicular, we can use this tan beta, we can get easily our result. Now I can write here tan beta is equal to, that is ON, base divided by perpendicular, that is QN. ON divided by QN. Sorry, we know tan theta is equal to, that is perpendicular divided by, that is we can write QN divided by ON. All right. Now we know that this QN, I can write this in the same way, and this ON is equal to, that is the sum of OP and PN. That is OP plus PN. And we know that this QN, when we talk about this QN, QN, we know the expression, that is QN is equal to the R sine B sine theta. If you remember the last expression, then I can replace this QN by B sine theta divided by this OP is equal to A vector plus, plus this Pn. This Pn is equal to, that is B cos theta, if you remember the last expression. And this tan beta, I can write here tan beta is equal to B sine theta divided by A plus B cos theta. This shows that if you know the angle theta, this is this theta. If you know this theta, what is the angle theta? You can put in both the sine theta as well as cos theta, and you will get this value. And then suppose this comes out to be 1 by 2. Suppose I am just telling you here, this comes out to be 1 by 2. Then I can write tan beta is equal to 1 by 2. And this 1 by 2, I can write this again, that is beta is equal to tan inverse of 1 by 2. All right, this will become our angle in this case, and this angle tells us the direction. Suppose we get this beta, you write this, just write this first. I'll write this first. Suppose you get this tan theta, tan beta is equal to, tan beta, not tan beta, that you get beta is equal to, angle is equal to 45 degree. What does this mean? Yeah, you get 90 degree this beta. What does this mean? How this 90 degree gives us the direction? You just know that the full circle, the circumference of the circle, the boundary covered by the whole circle is 2 pi, and half of this is pi, and half of this pi is pi by 2, and this pi by 2 is 90 degree. When you start angle that we start this in this way, that's in anti-clockwise. If we start this from this anti-clockwise, we get 10 degree, 20, 30, 40, 50, and this becomes 90, and this is our 180 degree. Now if you find this beta, this tan beta, if you find this beta angle 90 degree, this shows us that this is direction is along this. All right, if this comes out to be 45, that is along this. And you know that here is our west, this is our east, and this is our north, and this is our south. If this comes out to be 90 degree, that you can say this body is going towards north direction. All right, if this comes out to be 45 degree, you can say this comes out to be, this is between northeast. If it is 0 degree, you can say that this is along east direction. All right, this is all about this triangular factor addition, how we can find its expression, how you can get uh, the whole. Now in general, what we get is that the magnitude comes out to be r is equal to under root of a square plus b square plus 2ab cos theta, and it is, this is whole under root, and it is angle that's tan beta is equal to b sine theta divided by a plus b cos theta. All right, this is all about today's lecture. Thank you so much. If you find this interesting, like and subscribe our channel. Thank you so much. Thank you so much.